Matter is classified broadly into two categories called pure substances and mixtures. Matter that exists as only one type of substance are called pure substances. Matter that has two or more substances physically combined are called mixtures. Pure substances are further divided into elements and compounds. Elements have only one type of atom. Some examples are copper, hydrogen, carbon, and oxygen. Some elements exist as monoatomic elements, some as diatomic, and some can exist as multiatomic elements. Compounds have two or more elements chemically combined in a fixed ratio. For example, water, H2O, has two hydrogen atoms combined with one oxygen atom. Carbon dioxide has one carbon atom combined with two oxygen atoms. Elements and compounds have a constant composition. Mixtures are divided into homogeneous mixtures and heterogeneous mixtures based on the distribution of their components. Homogeneous mixtures have a uniform distribution and are also called solutions. Examples of homogeneous mixtures are sugar in water, salt in water, air, alloys like brass, which is a combination of copper and zinc. Heterogeneous mixtures have a non-uniform distribution. Examples for heterogeneous mixtures are oil in water, sand in water, copper pieces in water. Mixtures can be mixtures of elements, mixtures of compounds, or mixtures of elements and compounds. Mixtures can exist in different states, like liquid mixtures, solid mixtures, and gaseous mixtures. Oil in water is an example of a liquid mixture. Amalgams and alloys are examples of solid mixtures. Air is a good example of gaseous mixtures. Mixtures are substances that are physically combined. There are techniques that we can use in the laboratory and in industry to separate the components in a mixture. For example, filtration is used to separate a solid from liquid. Liquid-liquid extraction and chromatographic methods are used to separate liquid mixtures into their individual components. This set of diagrams show the representation of elements, compounds, and mixtures in different states. Each type of circle represents a different element. In diagram A, there's only one type of atom, therefore it's an element. Particles are far apart, therefore it's in the gaseous state. So it's an element in the gas state. Diagram B shows an element. Particles are loosely attached but close, therefore it's in the liquid state. In C, it's a compound of two elements in the gaseous state. Diagram D has an element in the solid state because particles are pretty tightly packed. In the bottom set of diagrams, we are looking at mixtures. Diagram E shows a mixture of two elements in the gas state. F is a mixture of an element and a compound in the gas state. G is a liquid mixture of two diatomic elements. And H is a solid mixture of two elements.